there are several different types of forces, some of which we'll study in this class and some we won't get to. And what I'd like to do is go through a few of the common ones and a couple of the less common ones so that you have a bit of a inventory of different types of forces that you might see. Okay, so one really common one is gravity. We experience gravity in our everyday life. Objects are pulled towards the ground by the earth, and that one's fairly straightforward. Another one that we come across pretty often is magnetism. Okay, so you probably have magnets stuck to your refrigerator. We use magnets for a variety of things. You know, all day we come across magnets in various applications. Some other kinds that are pretty common are, for instance, friction. So it's fairly familiar. If you are moving around, if you push an object, it'll come to a stop after a little bit because of friction. Or if you are walking, the reason that you don't just like slide and fall onto the ground is because there's friction underneath your feet that keeps you where you're trying to be. Another one that's pretty common is tension. So if you pull on a thread or a chain or a rope, we call that force a tension force. There's also just ordinary pushing forces. If you just use your hand and push against something, that is a type of force. There's actually a name for this, but I don't want to distract you with it just yet, so we'll come back to that in the next video. But just ordinary pushing forces. If you push with your hand or you push with some object against something else to cause it to move, that's a force. And then there are some other ones that are a little less common in our everyday lives, but are still, I think, reasonably familiar. So for instance, there's the buoyant force. This is the one that causes balloons full of helium to rise. It's the reason why some objects float in a pool. If you try to like push a basketball under the surface of the water in the pool, it's really hard to do because there's a really strong buoyant force. Another one is air resistance. So this is, for instance, the reason why a skydiver falls really slowly with a parachute open, because they have a really high air resistance. It's essentially just another kind of friction. It's just friction with a gas rather than friction with a surface contact. Another one that you come across from time to time is lift. So in an airplane, the reason why the airplanes don't just fall out of the sky is because, due to a variety of engineering considerations, they have an upwards force that we call lift. Okay, so these are some pretty common ones that you might see in your everyday life. And I've written them in two lists here because there are two different categories of forces. So what is the difference between gravity and magnetism versus the forces that are in the right-hand column? Well, the forces that are in the right-hand column all have to have the two objects be in contact with each other. So we call these contact forces. So you can't have friction between an object and something it's not touching. In order to pull on a chain, you have to actually touch the chain. In order to push on a wall, for instance, you need to actually be touching the wall, and so on. So all of those forces require contact. Gravity and magnetism are a little different, though. Those are non-contact forces. Okay, so you can bring a magnet near to a paperclip and the paperclip will jump towards the magnet. The reason is because it's experiencing a force even at some distance. So non-contact forces do not require objects to be touching. Contact forces do. And the reason why this is so helpful is because this will help you identify what the force is exerted on and what the force is exerted by. If you're considering a contact force, you know that the objects that are exerting forces on each other need to actually be touching, whereas that's not true for non-contact forces. Okay, so I've left some space here because there are a number of things that you might think of as forces that are not actually types of forces. And I just want to go over some of those here. Okay, so this last column, again, is not real forces, but they're ones that I want to talk about because they come up so often. So one is the net force. Okay, so in physics, we often add up all the forces on a given object and get a total force. And we have a special name for the total force. We call it the net force, but it's not actually a type of forces. It just means the total. Okay, so don't be confused. The net force isn't a new type of force. It's just the sum of all the other forces. Another one that comes up is centrifugal. So the quote-unquote centrifugal force is what you feel when you are, for instance, on a merry-go-round, or if you're in a car and you take a corner really fast and you feel like you're kind of flung towards the outside of the turn. And it's not really a force. It is sort of an illusion based on the fact that you're in a car and the car is moving sort of without you. You're not actually being flung towards the outside. It just kind of feels like you're being flung towards the outside. So that's not a real force. Another one that you might come across is centripetal. And centripetal forces are also not real forces. A centripetal force is just a name we give to a force that's causing an object to turn. So for instance, the Earth goes around the sun in a circular orbit because the Earth is always turning. There has to be some force that's causing it to turn. And that force is obviously gravity in that case. And we just call that the centripetal force. It's the additional name we give to forces that are doing a particular thing, but it's not a new type of force. A centripetal force, like net forces, will always be built out of friction or tension or gravity or some normal type of force, some ordinary force. Another one that comes up is torque. So a torque is also not a force. Torques cause rotation. So we'll learn about this in a few chapters, but essentially if a force is causing a rotation, then we may talk about the torque that is associated with that force. Any force may have a torque. Again, it could be a friction or a tension or gravity. but again, it's not a type of force, torques. It's just an additional thing that forces do, and we'll come back to that later. Okay, so the good news is any of those things in the right hand column you don't have to think about right now, because they're not actually forces. We want to focus on the ones in the left two columns, because those are the ones that are actually real forces that exist. Okay, so you might wonder, is this all the forces? How many forces are there? And the answer is actually there are quite a few more. So let me just go through some more unusual ones. So one is the electric force. So I'm just changing color because these are, I think, less common and a little, weirder. So the electric force is what you may know as static electricity. So if you rub a balloon on your head and then your hair is attracted to the balloon, that's a force, and that is what we call the electric force. There are also a couple of forces going on inside the nucleus of an atom. So I'm just going to call those nuclear forces. There are actually two. The one that's easier to understand is the strong force, as it is called, which is basically what keeps protons stuck together in the nucleus of an atom. If you think about it, positively charged protons should not want to be stuck together. They should all be repelling each other. And so there's this so-called strong force that's holding them together despite that, that repulsion. Another one that comes up is the spring force. So if you take a spring and then pull on it or push on it, the spring will compress or stretch. So essentially we could think of that as just an ordinary tension or an ordinary pushing force, but springs are interesting to study in their own right. So we'll come back to this a little later and think about how a spring operates. Another one is radiation. And by this I'm not talking about radioactivity. I'm talking about, for instance, sunlight. You may have heard of like solar sails, for instance, which can collect the so-called radiation pressure from the sun. So there are various kinds of theoretical technologies that could be able to take advantage of the fact that having light shining on an object actually gives it a tiny, tiny push. And then maybe that could be something that we use at some point in the future. There's not much we can do with it yet, but it is a different type of force that you may have heard of. Okay, so this is it for the types of forces. In this class, that we are not going to come across most of these, or at least not very often. I would say 95% of the forces we come across will either be gravity, friction, tension, or this pushing force, which I'm going to give you a name for in the next video.